Welcome back everyone. This presentation has been prepared and narrated by Mohammed Shazaib, Mohammed Hasib, Mohammed Urtaza Luqman, and Rana Umar Farid. We'll start with basic geometric shapes, then move into modifying, duplicating, and arranging them into a more complex structure. Selecting and modifying the first cube. The scene starts with a single cube present in the middle of the workspace. The user clicks on it, and the familiar AutoCAD 3D gizmo tools appear. Duplicating the cube, creating a pattern. Now the real pattern building begins. The user selects the Move tool and activates the copy option from the command line. Instead of moving the cube, they generate an identical cube slightly to the side. They repeat this motion, copying cube after cube, forming a neat row along the x-axis. Building the full cluster. With the basic grid completed, the user now begins to build vertical layers, turning the flat pattern into a three-dimensional cluster. They select a group of cubes and copy them upward along the z-axis. This creates the second layer. Then another copy is made above that, forming the third layer. You can now see the structure growing in height. The user rotates the camera continuously to check alignment and spacing from all sides. More cubes are added behind the structure, extending it along the y-axis. Then the pattern grows further along the x-axis, eventually forming a block-like structure with depth, width, and height. At this point, the model starts looking more complex, almost like a voxel structure or a simplified architectural massing model. Each cube still represents a modular building block, but together they form a much larger geometric assembly. Refining the arrangement. At this stage, the user focuses on refining the overall structure. They slowly orbit around the entire cluster of cubes, checking each side from different angles to make sure every cube is placed exactly where it should be. This careful rotation helps reveal tiny misalignments that might not be visible from a single viewpoint. Whenever a cube looks even slightly off, tilted, shifted, or not perfectly touching its neighboring cubes, the user selects it and makes a precise adjustment. Sometimes it's just a small nudge along the X, Y, or Z axis, but these small corrections help maintain the clean, uniform look of the model. AutoCAD's snapping tools play an important role here, locking cubes onto the correct edges and corners so they sit perfectly in line. As these adjustments are made, the pattern begins to look much more organized and consistent. You can also see how the aligned cubes catch the light more evenly. When everything is properly lined up, the reflections move smoothly across the surfaces, giving the structure sharper edges and a more intentional geometric appearance. This refining step transforms the arrangement from a rough layout into a clean, polished formation. (6) Adjusting visual style and shading. The visual style remains in conceptual mode, but as the camera moves, subtle changes in shadow and highlight reveal the individual cube edges more clearly. This helps the user identify any surface irregularities. The soft shading also provides contrast between each cube and its neighbors, emphasizing the overall depth of the model. Nothing is changed in the settings here. The user simply relies on the camera angle and lighting to better understand the form. Version. Now we move into the stage where the model starts gaining true complexity. At this point in the video, the user is no longer duplicating large groups of cubes. Instead, they begin zooming in and selecting much smaller clusters, sometimes just 2 or 3 cubes at a time. The purpose here is to break the uniformity and introduce visually interesting variations. First, the user selects a tiny set of cubes along one edge of the main block. Using the move and copy commands, they shift these cubes outward along a single axis, sometimes the x-axis, sometimes the y-axis, depending on which direction creates the most balanced look. These cubes extend just enough to create a sort of stepped pattern, almost like small architectural protrusions. Next, they focus on the corners. Corners naturally draw attention, so the user duplicates small cube sets directly from these points. When placed slightly offset from the original structure, these new cubes create a layered corner effect, adding depth and giving the entire model a more three-dimensional feel. Some of these additions form small terraces, while others act like anchor points that visually hold the structure together. After that, the user shifts attention to the top surfaces. Here, they carefully duplicate single cubes or pairs and reposition them upward, forming tiny platforms or elevated nodes. These little additions make the top surface feel more dynamic instead of flat and empty. Throughout the process, the user constantly rotates the 3D view, checking to make sure every added cube looks intentional and contributes to the overall balance. Whenever they spot an empty-looking area or a gap that disrupts the symmetry, they duplicate another cube to fill it, but always in a way that maintains the geometric pattern of the entire composition. As more of these small elements are added, the structure transforms significantly. What once looked like a simple grid of repeated cubes now starts to resemble a carefully designed geometric artwork. The combination of steps, offsets, terraces, and tiny extensions gives the model a sense of rhythm and depth. By the end of this stage, the model has a layered, sculptural quality, showing that even minor additions can dramatically change the complexity and visual appeal of a 3D form. With all the components now placed and aligned properly, the model reaches its complete form. The user takes a moment to adjust the view and then performs a slow, smooth orbit around the entire structure. This rotation allows us to see how all the cubes fit together from every angle. The layered edges, the small extensions, and the repeated patterns now stand out clearly. The structure looks far more organized and intentional than the simple cube array we started with. Every section has a purpose, and the overall design feels balanced and polished. This final overview shows how thoughtful duplication and placement of basic shapes can create a visually appealing and well-structured 3D model. And this brings us to the end of the modeling process shown in the video.